In July of 2025, the world of astronomy was shaken with excitement. A brand new celestial object was detected right here in our solar system. At first, astronomers assumed it was probably just one of the countless still unknown comets, thousands of which orbit the Sun. But the moment its speed was measured, it became immediately clear that this thing was something entirely different. The object's velocity was an astonishing 150,000 miles per hour. Hey everyone, and welcome! Just think about this. The third cosmic velocity, or the minimum speed needed to escape the Sun's gravitational pull, is around 94,000 miles per hour. That means this object, now called 3IATLAS, was unmistakably an interstellar traveler. This marks only the third time we've ever confirmed an object entering from beyond our solar system. The first to pave the way was Oumuamua in 2017, followed by Comet Borisov in 2019. But 3IATLAS wasn't just another passing visitor. Its orbit, its chemical makeup, and its bizarre behavior have completely shattered everything we thought we knew about comets. Thanks for tuning into our channel. The strange and baffling data surrounding this mysterious object is still pouring in as we speak. And today, we're bringing you the very latest on this cosmic enigma in full detail. A mysterious orbit. The fact that this object came from deep space was already clear just by looking at the path it took. Let's take a moment to revisit an important concept in orbital mechanics: orbital eccentricity. Eccentricity is a number that tells us how stretched or elongated an orbit is from being a perfect circle. If the eccentricity is 0, that means the orbit is a perfect circle, completely round. Values greater than 0 but less than 1 represent elliptical orbits, and the closer the value gets to 1, the more stretched and narrow the ellipse becomes. An eccentricity of exactly 1 indicates a parabolic orbit, which is right at the boundary between being bound and unbound. But if the eccentricity is greater than 1, then you have a hyperbolic orbit, the kind that comes from beyond the solar system, swings by once and never returns. For reference, Earth's orbital eccentricity is just 0.016, which means it follows a nearly perfect circle. Even Halley's Comet has an eccentricity of only about 0.97. But 3IATLAS? Its eccentricity was, unbelievably, more than 6. In other words, this object isn't captured by the Sun's gravity at all. It's simply passing through our solar system on its endless journey across the vastness of space. But all of this is really just basic celestial mechanics. What truly shocked scientists was something else entirely. It was the tilt of the orbit, compared to the ecliptic, the flat plane where all the planets, including Earth, revolve around the Sun. This object's path was tilted by only about 5 degrees. In simpler terms, it approached from almost the exact same plane where all the planets orbit, as if it had been intentionally aligned. The odds of such an alignment happening purely by chance are less than 0.2%. The size and shape of the nucleus. The next big question scientists had to face was this: just how large was this mysterious traveler from beyond? That's a critical question, because the size of its nucleus determines how long it remains active and how it behaves when it swings close to the Sun. Observations from the Hubble Space Telescope gave researchers a clue, at least enough to estimate the upper limit of its size. Once they subtracted the effects of the bright glowing gas cloud surrounding it, known as the coma, they concluded that the nucleus couldn't be larger than about 3 to 4 miles across. But to be clear, the exact measurement is still unknown, and it's entirely possible the actual size could be as small as just a few hundred yards. So in simple terms, it might be a boulder the size of a city, or it could be a massive chunk of ice as large as an entire mountain range. Or maybe something artificial. But as long as that coma keeps covering up the core body, the truth will stay hidden in the fog of uncertainty. A chemical shock. When the James Webb Space Telescope joined the effort to observe 3IATLAS, scientists were hit with a jaw-dropping discovery. Analyzing the spectrum of the coma revealed that the ratio of gases surrounding the object was highly unusual. It contained nearly 8 times more carbon dioxide than water vapor. That's something you would never see in a typical comet from our solar system. Normally, water is the dominant component, and carbon dioxide is present in quantities many times smaller. But that, it turned out, was just the beginning. Further analysis uncovered even more surprises. Organic molecules, sulfur-based compounds, and even isolated atoms of nickel were all detected in its chemical makeup. And yet, oddly enough, almost no iron was found at all. Under normal chemical conditions, nickel and iron are practically inseparable. They always show up together. But in this case, they had been completely divided. This strongly suggests that 3IATLAS was born in a completely different kind of environment, in the cradle of a far-off planetary system that's unlike anything near our Sun. A place where carbon dioxide was far more abundant than water, and where nickel could evaporate on its own without being bound to iron. So what we're seeing isn't just a visiting comet, it's a fragment from another solar system, one that may be far older than Earth or even the Sun itself. And even its appearance set it apart from every other known comet. The coma had a faint greenish glow. Normally, that kind of green light comes from diatomic carbon, or C2, which glows under the influence of ultraviolet rays from the Sun. But as of July and August of 2025, no confirmed detections of C2 had been reported from 3IATLAS. In other words, 3IATLAS is quite literally shining with an alien light, an eerie glow from another world, leaving behind a trail of unanswered questions. A strange jet. But the biggest shock of all wasn't about chemistry, it came from the behavior of the comet itself. Telescopes all around the world captured an utterly bizarre phenomenon. From the side of 3IATLAS that was facing the Sun, a bright and steady jet of material was shooting out with incredible force. And get this, the direction of that jet was completely reversed. While all known comets have tails that blow away from the Sun, this one was blasting directly toward it. News outlets wasted no time jumping on the story with bold headlines like "A comet with a reversed tail." Was this a major astronomical event? Scientists quickly stepped in to cool things down and clarified that this wasn't the usual tail, which always points away from the Sun due to the solar wind. Instead, this was a localized jet of material erupting from just one part of the coma. It's believed that beneath the surface of the comet, there were pockets of carbon dioxide ice concentrated in specific regions. When the Sun's heat hit those areas, the CO2 suddenly vaporized, creating a powerful outburst strong enough to overcome even the force of the solar wind at close range. So, was it really not such a sensational event after all? No, it absolutely was sensational. Because when scientists tried to run simulations based on the CO2 vaporization theory, every single one of their models broke down. None of them could account for the jet's stability or for how tightly focused its direction was. They tried changing everything: how fast the nucleus was spinning, how big the dust particles were, even the surface temperature. But nothing worked. The predictions from every simulation simply didn't match what telescopes were actually seeing. What astronomers were witnessing was a phenomenon unlike anything they had ever seen before. It was as if 3IATLAS was announcing to the universe that it didn't play by the same rules that govern ordinary comets. Clues that point to propulsion. But the strangeness didn't stop there. Astronomers began comparing 3IATLAS's actual trajectory with detailed calculations based on classical gravitational theory. And sure enough, while the difference was small, they found a measurable deviation from the predicted path. That tiny discrepancy continued to build over time, and it was always in the same direction, toward the Sun, just like that mysterious jet. But when they adjusted the models to include a non-gravitational acceleration of about 4 × 10⁻⁷ meters per second squared, the match with the observations became nearly perfect. That's a force so faint it's like the weight of a feather resting in your palm, yet it was acting on a massive block of ice weighing millions of tons. In space, even that kind of whisper-thin thrust can shift an object's path by thousands of miles. And that led some scientists to start entertaining bold new theories. Maybe it wasn't just an unusual outgassing event. Maybe something even stranger was at play. One of the most talked about ideas came from Avi Loeb, a well-known astrophysicist at Harvard University. He proposed that maybe, just maybe, 3IATLAS wasn't a natural object at all. What if it was some kind of artificial probe using the principles of an ion engine to navigate? To him, that tight focused stream of gas looked suspiciously like a controlled jet of thrust. But that idea was more of a metaphor than a literal claim. After all, real ion engine exhaust is invisible to the human eye, while here, the plume of carbon dioxide and dust was clearly observed. And more importantly, the jet was pointing toward the sun, which under the laws of physics would cause deceleration, not acceleration. So the idea that this was some kind of propulsion system doesn't hold up. In the end, as unusual and baffling as it may be, what we're seeing is still the result of a natural phenomenon. Echoes of Oumuamua and Borisov. This isn't the first time a visitor from another star has left scientists scratching their heads. Back in 2017, we were introduced to Oumuamua. It had no visible tail, no jets of gas, yet it kept accelerating in a strange, unexplained way. At the time, some even speculated that the mysterious thrust might have come from an alien solar sail technology. Then, 2 years later, a second visitor arrived. Comet Borisov entered our solar system. It looked exactly like what we were used to: glowing coma, classic tail, and a chemical makeup not far from that of our own comets. Thanks to Borisov, we were able to breathe a little easier, comforted by the idea that maybe not everything out there was so alien. But with the arrival of 3IATLAS, the story took another dramatic turn. Yes, it had a tail, but the way it moved was undeniably strange. Yes, it had gas, but the proportions were wildly abnormal. And yes, it experienced acceleration, but in a direction that defied everything we know about physics. Every time one of these interstellar visitors shows up, we're reminded of a hard truth. The rules of our world don't necessarily apply to others. Oumuamua, Comet Borisov, and now 3IATLAS. These are not isolated events, but 3 chapters in an unfolding cosmic saga. And with each new chapter, the mystery only deepens. And the most suspenseful moment in this entire story is still ahead of us. At the end of October 2025, 3IATLAS will make its closest approach to the Sun, just 1.35 astronomical units away, slightly beyond Earth's orbit. And right at that moment, it will slip behind the Sun, vanishing from our view. This event is known as solar conjunction. No optical telescope, no radio dish can see through the blinding light of the Sun. And if something dramatic happens during that time, an explosive outburst, a sudden change in trajectory, even the breakup of its nucleus, we won't be able to witness it. 3IATLAS will reappear from behind the Sun several weeks later. And only then will we finally learn whether something truly extraordinary happened to this third visitor from the stars, out there in a place where our instruments couldn't follow. A message from another star. 3IATLAS is no ordinary comet. It carries the chemical fingerprint of a different star system, defies the laws of physics as we know them, and disappears at the very moment we most want to observe it. It is a messenger, traveling across billions of years to reach us. It may have been born in the frozen void of deep space, perhaps near a distant red dwarf, before being cast out, wandering across the galaxy for millions of years. And now it's passing through our solar system for just this brief moment, leaving behind nothing but questions and mysteries, before vanishing forever. When it finally re-emerges from behind the Sun, astronomers will turn their telescopes toward it once more. And in that moment, even the tiniest piece of data, a single spectral reading, a lone photograph, could be worth its weight in gold. Because these fragments might tell us something about a faraway world we may not lay our eyes on for countless generations. Or maybe we won't see anything at all. Maybe 3IATLAS is nothing more than an unusually odd comet. But then again, history is full of wild theories that turned out to be absolutely true. If you enjoyed this video, be sure to give it a like and share it with your friends. Thanks so much for watching. Until next time, take care and goodbye.